when you look at that, try and put it into words. When I look at it, it changes. It changes the probabilities of different kinds of successes.
Right. If we start with the basic one, which is the green, right?
Right.
The green is the only boring one. Green is your basic success.
Exactly.
It's the only boring one. Right. It's the same width the whole way, and it doesn't curve at all. Right?
Right.
And so what we see is that it shifts down, basically. Or wait. No, it shifts up as you get better, right? It's more likely that you'll get that on the lower rolls. So what you're really doing is you're squeezing the bad result, the shitty result, into a really tiny little funnel there. But you're not changing. You have basically, no matter what your ability, you have exactly the same chance in terms of raw percent. You have exactly the same chance of getting a basic success. Isn't that interesting? You don't change your chances of getting a basic success no matter how good you are in this system.
Right.
Is that what you were aiming at?
Right. That's what. Yes, exactly. Because it does change your chances of getting.
Well, a chance of getting a success at all, obviously.
Right, and then better successes as well.
Right. You'll notice that green line doesn't go from the bottom left corner to the top right corner. It's not. It's canted, right? It's shifted down a little, and so that's kind of interesting too. It means that there's a fairly substantial chance of failure. It's a disproportionate amount of failure over there in the crap zone. Right. So I might not have canted it right in my mind. Maybe I said that wrong. I think that the position of the green line basically means that almost no character is truly wretched. Even with bad scores, it doesn't take you all the way down. The white doesn't go all the way down to the bottom left corner. So, so even if you're not so good, there's still some green for you there. Right?
Yeah.
All the way. That's what I meant to say. Yeah. So, okay. So with those in mind, I'm interested in the change. I mean, the fact that the shapes of the other colors, white and red and yellow, I'm interested in how their shapes are not just stripes like the green. Right? So if you've got the shapes that are not just the stripes like the green, then you're getting effects like what Sean's talking about. You're getting effectively not the same thing I was talking about with the bell for the 3-6, but you're getting some kind of interesting emergent properties because of the shapes, because of the curving shapes. So actually it is a little bit similar in that if you go up, if in Marvel superheroes, what you're looking for a lot of the time are what are called column shifts. You roll, but you have a column shift on your side, so you're going to take one better column than you got. Right? That's one of the things you want.
I was going to say about remarkable or incredible.
Right.
Is where it starts, like, even though it's 5% less green, but there's more yellow than there is red. It looks like getting that median result, the yellow results, are what you really want to aim for.
Mm-hmm.
That's almost, I don't know I'm using it right, but it's almost a curvature in successes, because at the end, yellow is the most common result, I think.
Mm-hmm. Right. So if you want to shift into the zone where the yellow becomes the most common. is what you're saying, right? So the point is that this has properties, although they're not identical to the bell. There are bell-like issues going on in the table because of the curves, right? So this is what I look for in any flat distribution system. In a flat distribution system, I'm interested in when the table starts acting funny, so that I can say, okay, well, it's like this. I mean, it's equivalent or it's similar to the simple effect of the bell curve with the 3d6. What's kind of interesting is that you can get, if we just stick with this kind of method where you roll multiple dice and add them up, you can get some really interesting observations. One is that you don't need much. Even, I mean, if it weren't for the effect I'm talking about, playing craps with 2 dice would have no interest at all. Right? Even the gentle curve of 2d6 is enough to make gambling interesting. Or, if better, challenging. Right? It's enough to drag your attention to, I can play these probabilities. And some people are actually good at it, which baffles me, but they are. And then you have other situations in role-playing. Since that range of 1 through 20 is really easy to grasp, you also have 2d10. And 2d10, which was used for a game called Pocket Universe, and especially for DC Heroes. And that's been very influential. It uses a table that's very similar to what we're talking about. In DC Heroes, you have 2d10, and it also is a gentle curve, but something about that curve and that range is extremely satisfying. You can really feel the difference in the middle, just like you can with the 3d6. And then we have the interesting thing that Lorenzo's doing, where he has 3d6, and you roll them, and the way you modify the roll is that you can replace one or more dice with larger dice. So you might roll, for example, 2d6 and 1d10. And he also has, it's a little complicated, he also allows rolling extra dice, but again, you only keep the highest 3. So what he's doing is he's taking a 3d6 roll and he's allowing modifiers that either shift it to the right because the range is now higher. Actually, it shifts the ends to the right. The bottom stays at 3. And the top will shift over to the right. He lengthens the results. And then by having extra dice, but you only keep the 3, he's actually tightening the bell. He's making the bell higher and tighter. So that's how you modify. You get a higher possible result, and you make your bell higher and tighter. That's what his modifiers do. So it's an interesting way of doing it besides just +1s and -1s. So that's one reason why I wanted Lorenzo here. But okay, so knowing that you can, modify these both by adding bonuses and penalties to a fixed system, or by messing with their mechanics so you can change the curve, right, as you go. That kind of gives us perspective now for looking at these percentage systems or percentage equivalent systems and saying, what are we going to do with Legendary Lives? If we go to the Legendary Lives table, the last one that Ross provided, you can see a couple of interesting points. One is that it does, the midline value does go from corner to corner. So that's just one interesting observation. You can also see that although the values curve, they curve very symmetrically. So it doesn't have that asymmetrical quality that the Marvel table has. Now it's a little more, we have to be careful because in Legendary Lives, in Marvel has 4 results, right? Crap, miss, good enough, and, great. The 4 colors. Whereas in Legendary Lives, there are in fact 10 plus colors. They're with very careful gradations of failure and success written out. But can you see what I mean about the symmetry? So the basic idea that as you go up, yes, you have more chance, your chances of the results you want actually do become higher as you go up. But there's something about it that's still in play, feels like you're just throwing everything into a blender. You might as well just be rolling. It almost feels as though you've got a 50% chance of success, no matter what. Or more accurately, that you roll and it really is just up in the air what's going to happen. The correspondence with how good you are in play after all those sessions that we played really is distinct in comparison. So I'm trying to figure out, is it the fact that it goes from corner to corner, and is it the fact that it's completely symmetrical on either on the successful side, the lower right corner versus the higher left corner? Is it the fact that it's symmetrical? Does that matter? Is that giving me that weird outcome during play? You'd think it wouldn't. You'd say, okay, if I've got a 17, if I've got a value of 17, you can find it on the table. If you got a value of 17 and you roll, the distribution looks great. It doesn't look so bad. But something about it is frustrating. And I'm still not sure I can say why, but I just know that when I look at those 2 tables and I see the symmetry on one and the asymmetry of the other, and I think about the difference between, a bell curve and a flat distribution, and I say to myself, is that what it is? Is there something that happens on the Marvel table that doesn't happen in Legendary Lives? What is it that we're really looking at when
the thing that strikes me about the Legendary Lives is that the symmetry erases failure to a large degree. Eventually, at the top, there's no more white, there's no more gray, and I don't know the game system, so I don't know what is and is not failure or push or whatever.
Right, the green line is the green and above are successes. Okay. Right.
Okay, so every other color below that,
right,
is a not success.
Correct.
Interesting.
Mm-hmm.
So it doesn't. Okay, so it doesn't completely erase, but it does completely erase the red, the white, the gray, and the red at some point.
Mm-hmm. Well, I think there's always a chance for there's a 1% will always stay with you.
Okay.
But the tricky thing I'm trying to get at is that, okay, part of this is another phenomenon. In Marvel superheroes, having those really, really high values is not only possible, but because you're playing superheroes, it is more or less expected that you'll have something, or that some characters will have something way up there. In Legendary Lives, you're not going to be running around with values of 24 and 25. The last few columns you just never see in play. You'll have to have a value of 18 or 19 is fantastic. So that's another part of it, is that the extreme right hand of the table, the extreme rightward end of the table, really doesn't occur in play particularly.